I think it was October, Martin, when we spoke after the last meetup, and I talked a little bit about what Singularities was doing with our machine learning algorithms and how we were running on Spark, and he said, oh, that could make a good talk. So you can tell me afterwards whether it was a good talk or a bad talk, but let's get started. So just a little bit of background to me. I'm the CTO for Singularities and also the founder and CEO for Data Wranglers Limited, a London-based boutique consulting company. But essentially I have about 5 years experience working with big data. So from the earliest time was with Full Tilt Poker, an online gaming company, and we use it for fraud detection. And so we had a system about 30 terabytes in size across about 45 servers. And then when Aster Data was acquired by Teradata, I came on board as their director in their Center of Excellence and spent 2 years on planes. But that gets boring after a while. So prior to that, I kind of was a developer, a senior developer, working in for Informatica around the data quality, data profiling business unit, and I was a long time a big old red of Oracle. And I founded a group called the Migration Technology Group. Now, one thing that struck me when I was putting this slide together is that a lot of my career has been working in closed source. So where like Oracle does have an open source policy, none of the stuff I ever worked on was open source. And same in Informatica, and same in Teradata. But what struck me was that it came back to the very early part of my career when I was a Unix guy. So this when Unix was Unix, it's not called Linux. I had this Berkeley distribution that I used to use. And you did have dialects. You had like Plan 7, Plan 9. You had System 5, Release 4. But one of the things that struck me was that the openness of that environment. And also the fact that within that environment, when you were doing data manipulation or some analysis, you just strung tools together in a pipeline. So you had awk, grep, sed. If it got really complicated, you used yak and lex to parse it through. But what happened was that each tool did one thing properly and then interfaced down the line in terms of pipeline. And that sort of concept has really kind of stuck with us in Singularities. In terms of what we really want to do is what we're good at, which is the modeling, and the cognitive functions. And then we want to partner with other companies to be able to create a business solution. So in that way, we needed to have a common platform by which we could communicate. And one of those things as an execution environment, Spark is very important to us. So just quickly kind of set the scene of how we use it. Have a look at our system architecture. I will briefly get into the Spark versus Flink debate. But well, I'm not a religious zealot here, so I ain't got any hound in that game. And the other one that I wanted to kind of cover off a little bit is that if you're developing a hosted application, having a look at the Lambda-based architecture of how you run Spark applications is really important because you can be very cost competitive in that way. And then I wanted to talk a little bit about the evolution where we use different machine learning algorithms and some of our philosophy behind which algorithms we choose and how they compare for us. And then some areas that we want to look at in the future. So really, where does Singularities fit? We really are in the proactive decision making. So we're in the predictive analytics space. So we're using machine learning to create models. From those models, we can run simulations, or we can apply different cognitive functions. So if you think about the lower half of that screen is your traditional transactional business intelligence, where really what you want to try and get into that proactiveness. And this is also like around where companies are doing things like changing the business model, how to adopt a data-driven culture, how to be disruptive in their industry. And you all know, like, for example, the Uber story where they don't have any taxis. Netflix don't have any cinemas. Probably the largest bookstore in the world has very little bookstores. These are disruptive technologies that can come in and change the game. And how do they change it? Like Airbnb. They don't have any hotels, but they're all about data and all about managing and being able to predict. Their value is in their data. So what I've noticed in terms of being involved in this space for the last number of years is that Hadoop has become, it's 10 years old this year. It's become a lot more mature as an environment. I think technologies like Spark have really accelerated the sort of adoption. But you've also seen is that the major vendors in that space, whether it's Mapper or Hortonworks or Cloudera, are all playing pretty nice with each other. You know, they're contributing back their changes, and then they're trying to establish their own unique value proposition. What I do notice is that, and this is probably why some of the valuations of Teradata aren't so good at the moment, is that traditional closed source data warehousing vendors have really worked with relational data and operational data. And when you're trying to understand more about the individual, you're trying to get at their beliefs and behaviors. You're trying to get at them where they're maybe interacting with you on social media. So you're taking lots of different types of data sources. And they don't work so well in a traditional data warehouse. So the other thing that I've noticed and seen changing is that where a lot of the work originally was done on-premise, I'm seeing more and more companies are now willing to go off-premise because it's changing from being a CapEx expense where you have to play nice with your IT department and beg and borrow and whatever, to an operational expense for a business unit. Saying, if you got the money, you can play. And it's normally a fixed monthly charge. So what I've seen then is that emerging from that, a whole new suite of tools, a whole new ecosystem that built on top of Hadoop and Spark. So whether it's kind of data wrangling from companies like Trifacta, which has, and Tamar is another one in that space. And two things that I like about those companies is that they use machine learning as part of their discovery process to try and give you information to help you wrangle their data. So they're quite, or tools like visualization tools from companies like Zoom Data that leverage the open source D3 library. So if you don't like the graphs that they provide and you like one in D3, it'll plug right in. You also have the emergence of Hadoop as a service. So I've noticed a couple of different companies coming into this where they're offering Spark as your execution platform, but this would be, Altiscale has been trying to do this in a hosted environment, but one also interesting one is a company called Qball, which kind of abstracts you from Azure or the Google Compute or the Amazon AWS. So you can now kind of broker and say, which is the best environment for me to run this workload on? So this is important for me from as a hosting provider. So what I'm seeing is that you're moving from platforms and tools, platform tools and consulting. So here, like in London, you know, you've got Mike Merritt Holmes and a big data partnership, have a lot of skills in that area. You've got, if you're into machine learning, Alex Housley and the Zeldin IO stuff is really interesting in terms of providing you a platform to run multiple of these algorithms. So I'm, you know, pretty impressed with what's happening here, you know, in terms of some of these companies. So really what we try and do is that we use Spark as our kind of execution platform. So where we run our machine learning algorithms, where we run our large data wrangling jobs that we have to execute. We have multiple data sources, and we use this term called blueprints. So basically, you're in a lab environment. You're trying to say, is there value here? So I tell this story where that you have like raw data. You wrangle it, you get information. You apply advanced analytics, you gain insight. But you don't have, value doesn't happen until you execute, until you do something with that insight. It doesn't magically just become valuable to say, oh, here's the answer. Okay, now go do something with it. So there's an operational aspect to this predictive analytics as well as the research and discovery aspect. So very quickly, we work with models, and we use machine learning to create those models. Underneath the covers, it's an informational modeling, so it's a mathematical-based system of rules and equations, and that's how we're able to do this beliefs and behavior system. So that's different in a way to the neural network. So you've seen a lot of kind of announcements recently where TensorFlow, I think, which is the Google one, and Microsoft released one, and I think Alibaba released one in terms of neural networks advanced learning. And they're very powerful, especially as some of them are running on GPUs, if you have that in your environment. But the difference between this and what we do is that with a neural network, you get an answer. You just can't tell why you got that answer. Because ours is mathematical based, we know exactly why we've given you the answer. So the first kind of version is using Spark MLLib, Trifacta for wrangling, and Zoom data for visualization. Okay, Spark versus Flint. This is very interesting, actually. So we started off with Flink, and we had recommendations from a number of university professors that we knew. And a lot of it was on the element of saying, you guys will want to do real time in the future. So you want to be able to deal with streaming data. Flink does that. So I said, okay, let's do that. Talk to the developers. Said, yeah, no problem. We can handle that because we just come from prototyping under MapReduce, so anything was better than this, right? So although 5 years ago I thought MapReduce was brilliant, but so we were productive quickly with it. We had something built up, and then we hit a problem that we just could not debug. We just couldn't get to an area why it was failing. So then we started to look for documentation. No documentation. We started, what's the communities? No pointy-haired nerds tell me what the answer is and where I was stupid. So I said, after about 3 or 4 days doing this, I said, okay, we can't, we could be at this for weeks trying to debug this code, so we switched. And within about a couple of days, we were up and running on Spark. And we know this very easily. There's a huge community out there. There's good documentation. All of the platform vendors are supporting it. IBM's chucking a huge amount of money in it and training their own consultants to be able to. So I kind of gone, okay, I'm not going to fight that battle anymore. But I still have kind of architected it in a way that I could take in a different runtime in the future. But I think probably what we will see happen in the post 2.0 version of Spark, you're going to get them, those micro batches that they have as part of the design tree will get smaller and smaller and smaller until it really looks no different to streaming, or unless they're going to kind of come up with something new. But I noticed is that when I answer kind of questions on forums or respond, I'm Irish, so I am opinionated, right? So I can't help it. And so when I got bitten by Spark or by Flink, I do respond when someone tells me Flink is the most amazing thing in the world. And I go, well, it wasn't for me. But I tend to might write 2 or 3 lines in a comment on LinkedIn, and I'll get this 100-line missive back saying, but in the future, you will, I go, okay, but I live now and I need to build something now. So why do my developers love Spark? Well, first of all, we started on MapReduce, so that's not hard. It's also this kind of iterative processing that we can do and how we can look at our algorithms and start to try and parallelize them. I think is that, again, it's ubiquitous. I think also is that Spark is making our lives easier. So like in Spark 1.6, there was a lot more done in memory management. So I could become a lot dumber, okay? This guy's going to do it for me. And I like that way in which they're evolving and saying, okay, we'll take that heavy load. We don't want everybody to become, Java, JVM gurus and decide what way things are being configured. We'll be able to do that better in the future. We use Parquet as a kind of our file format that we pass around within the product because it allows us to kind of capture metadata as well as real data. The number of languages support, and really the community. And if you look at the growth and some of the kind of, you'd see that with Databricks guys when they present to kind of say, last year at this conference we had 500, this year we have 1,500, You can see that is growing. So in terms of our architecture, because we're a multi-tenanted application, so we support multiple customers, but through a single web app. But what we do is, because we're dealing with sensitive data, we basically provision storage and compute on a per customer basis in the cloud. So the customer can say, I want to be in London data center because my data cannot leave the UK. So we'll use the Amazon London data center and Spark it up there. Or somebody's saying, I'm in the West Coast, I want to be in the West Coast. Or if you're really paranoid, I'm financial services, you've got to be in my shop. I go, okay, if your server looks like this, we can be in your shop. But essentially what we're trying to do is, using the Spark architecture, is kind of share as much components as we can, but really it's the kind of the job runner and the file storage that we have to provision individually for each customer that we would push live. So this is just looking at one machine learning algorithm, which is looking at for frequent item sets. So this is one where you're trying to look for associations and you're trying to predict future behavior. So if someone buys milk and bread, Why are they buying beer? Well, I know that. But when someone's buying milk and bread, what's the propensity for them to buy beer? Or how could I predict that behavior? So as we can see, so Mario, this actually came from one of my developers actually gave me this slide. I'm actually going to have to talk to him, because he must be drinking way too much. But so Vladimir likes his vodka. But so what the association does is that for a given set of clients, we try and work out what's the most common associations. And in that way, we can start to try and predict, use that as a means of predicting future behavior. Let's let this build. Oh. So other times with this a priori algorithm, which is an independent of Spark, but we made it run on Spark, and we can say, we can kind of deduct, like if it appears this time, then it's more likely that it will appear in the next time. So here what we see is we have 4 occurrences beer, 2 occurrences wine, in the same way, all items. And then you can also set a limit so that it's only a certain set of objects become meaningful. So you kind of cut the tail end off your analysis. But get down to the more interesting thing now here in a moment. Okay. So that's an algorithm we can use. We ran it up on Spark. In general, what we found is that it runs really slowly because it's creating all of these tuplets of combinations. And it's kind of going through the data more than once. So the larger the data set you feed it, the slower it's going to be. So from our point of view, something that's running in a scalable cluster, this is not really something that we want, an algorithm that we wanted to use. But we now were able to decide from our analysis what was a good algorithm, what was a bad algorithm. So we started to have the basis of looking, and that's in a way, when you're looking at machine learning algorithms, one size doesn't fit all. There's lots of them out there, and depending on your data set, different ones may yield better value for you. So I'm not saying this is the one you should always use this one. No. Just be open to using different algorithms. The other thing that we have sort of made a decision on is from within leveraging those machine learning algorithms out there is that we'll have the notion of a private algorithm and a public algorithm, because you have within financial services companies, data scientists who have built these really, really smart machine learning algorithms that help them from financial transactions analysis. Clearly, they're not going to put that in open source because that's the core of their business. But they may want to leverage the platform. So that's the notion of a private algorithm. The other thing that we'll have is that they'll be version controlled, so that you might want to run version 1.5 and 1.6 side by side and say, do I get the same answer? The other things to think about are, we are open to taking anybody's machine learning algorithm in, but they'd have to give us source code, because I'm not running anybody's jar file in my environment that I can't understand what the source is doing. So I'll sign NDAs and all like that, but no, I'm not doing that otherwise. So this is an algorithm in MLLib called FPgrowth, and it's designed for these frequent item sets. But it understands this map-reduce model. So it tries to create the parallelism that I was looking for. It uses these frequent pair trees as a kind of the core concept. And the other thing I noticed is it nearly just does one pass on the data. So as you can see for some of these numbers. So we have Mario and his set of transactions. So we basically, first of all, we count all the individual items. And then with that threshold, so we say we're applying a threshold. If it doesn't happen twice, it's not really interesting. I don't want to know the one-offs. I want to know the things that you more frequently buy so I can predict. So that kind of covers off diapers. So then we sort that list. So we now have a sorted list that we can work from. Let me build this. So it builds a tree basically. And then as you feed in more, way too many builds in this. Come on, guys. I'm never going to build another slide again. Okay. So again, what it's looking at, ones where below those thresholds, like the cheese and bread here, will just get knocked off. Will just get knocked off. Yes. This should have been, yeah, okay, good. And then we start to get what was the most common set of products. So essentially we're able to use in a kind of MapReduce way, we have this sorted lists. So the advantage for us is that it's highly parallelizable. So that's really nice for us. So the bigger the data set, we can spark up more nodes in the cluster, get the answer in the same time. The thing that we find out is quite heavy on memory usage because it keeps a lot of things in memory. And if you then spill to disk, you hit a performance kind of degradation. But we're also looking at maybe attaching on something like Tachyon, which is another kind of memory management capabilities to kind of make that more less impactable. So just to show a Priori versus FPgrowth, we did some market basket analysis. We didn't see too much of a difference in that type of algorithm. When we did the first sort of recommendation list for a client, we basically, what we tend to do is that, because I don't get it right first time very often, I normally start with a very small data set and try my algorithm or my approach and then build up and build up. Rather than say, okay, we're going to go for this. Here's a 5 terabyte file. I'll come back. No. I start small first and I build up. So we can even start for that small size that we were seeing performance improvements. And then as we got up to larger sizes, a Priori just, said, nah, I ain't doing this anymore. This is not me. So again, you'll start to see that certain algorithms will work for certain data set sizes and then will just fall apart when they get to a certain threshold. So it also then depends on the size of your data set. So one of the things that we did, and I've sent some emails to the Databricks guys about this, was the way FPgrowth is written at the moment, it has to work one pass across the whole data set. But because I want to model individuals, people's beliefs and behaviors, I want to do it on a per customer basis. So in the default way that the FPgrowth algorithm, that would mean I have to call the FPgrowth algorithm multiple times to do that. So we kind of hacked some code and changed it around so that it works for us for having multiple customers in the data set. So most of the kind of research books we read has this just one pass on a data set, but for what we wanted it to be is being able to work on a per customer basis on the data set, because that was much more efficient for us. So we're happy to contribute that code back and just want to kind of understand from the developer of it, was something else going on in his mind why that was. It works for us this way, and we're happy to provide it. So some of the future Spark plans that really interest me is Spark 2.0 that's coming out in April or May sort of time frame. Our migration path from 1.5 to 1.6 was so easy. Like I said I remember mentioning at one of our morning stand-up meetings, and I said, we must move to Spark 1.6. And then the next day I said, I'll create a backlog item for moving to 1.6. And they go, no, we've already done it. So it was that easy. So that's nice. We'll move to using data frames. There's a lot of kind of changes going on in that in the 2.0 timeframe. So we'll fully kind of embrace that. They must be hiring marketing people now, because they call something called structured streaming, okay? Which is a streaming API. But really, when you look underneath the covers, there's still micro batches. Lads, that's not streaming. But it's getting closer, but it's not streaming. And then also they always seem to be able to make it go faster and put in improvements. So one of the areas that when we are developing a solution is we want to try and provide people with a rich environment they can work in. So our target initially is somebody that is a business analyst. Okay, so it's not the data scientist, because we all know if your data scientist is good, your salary expectations are going up every month. But there's clearly not enough data scientists to go around, if we believe what they say in the papers. So, but we do know that business analysts know their data. They're normally, you could classify them as being Excel power users. They maybe know a bit of SQL. Maybe some of the smarter ones have heard of Python. But at least the first two you could take as a given. So we want to provide them with a more sophisticated notebook interface and allow them to kind of operate in that sort of environment. Rather than, we have a menu-driven interface at the moment that really it just, click the button, select the things, off it goes, creates the Spark job. But we want to kind of give you that kind of, you're in a notebook and you're working through. And that's really what Databricks, which is the company that is kind of the commercial entity behind the guys that invented Spark, have done. That's their core product. So I tried to talk to them about, say, okay, can we OEM your product put it into ours as our notebook interface. But they're not there with that yet. But I do believe they will have a community edition of Databricks coming out pretty soon. So that should be the first kind of step along that way. The other one that we looked at, or are looking at, is Apache Zeppelin, which looks quite interesting. It is a bit of a slap to get configured and up and running. But I'm hoping is that we only have to do that once and that it won't take us, because we're managing everything, that it will be transparent to a customer. There's another one called Project Jupyter that I just came across today. And so I haven't really looked at that one yet. And then there's another one called Beaker. So we're basically going to look at those for interfaces, notebooks, and pick one. And again, because it's not our core competency. Our core competency is working with models, is being able to do the cognitive functions. Okay. And I think I did it in under 30 minutes, Martin. So we have a room for maybe 1 or 2 questions, if anybody has questions. And Rod at the back, you're not allowed to ask me questions. We work together, you can't ask me questions. Any questions?
So you said you don't like neural networks, but not you don't like them, but you don't use them because you don't understand the answer, you don't understand how it came to the answer.
Yes.
So
no, it doesn't mean that I don't like them, because I do like them, because they're powerful. It's just that in the predictive analytics that we're providing, we're trying to eventually kind of be able to prove why we made a recommendation about a given entity.
So are you using, so what are you using in an alternative, and how does that fit in Spark? Are you using Bayesian nets or something?
No, we're not, no. So the founder of Singularities has been working in this area for more than 15 years. So he's kind of developed an AI system that's based on this information modeling. And in that is basically a set of rules and equations. So we're basically using mathematical functions to do this analysis for us. So if you'd like to learn more, on the Singularities website, there's a technical white paper that kind of goes through how we do that. But essentially, it's not Bayesian, definitely not anywhere like that. So it's very, very different from that respect.
Well, you mentioned that sometimes the algorithm only showcases calls during increasing in the data set, but what we found is that often Spark's heuristics stop working at a certain data set size, for example, like number of partitions. And you only notice that after the algorithm has been running for 4 hours and you realize that it's just the data is
yeah.
very shuffling, you notice it only 4 or 5 hours. Do you have any solutions to that?
So what we're trying to do in that is that we're going to work with the Spark job system. So that's how we kind of submit it. But we're also looking at other ways that we can get lower level heuristics, that we can kind of say, is everything okay? So we hear here, everything's fine, everything's working, but we're trying to get some lower level statistics that we can feed in. We're also going to try and get smarter around when you give us an algorithm to run and you define the parameters, we'll know what the sort of impact the parameter change might have on the execution of the algorithm. And also then we'll know the data set that you want to feed to us. So one of the things that when you can do in a hosted environment that you can't really do in a real environment is we can say, okay, your current cluster has like 10 data nodes in it. We would recommend that we spin up to 20 to run this job. If you want to have it back in a reason. It may still run in 10, but it's going to take a long time. So we have the advantage that for being in a hosted environment, we can spin up for short amounts of time a lot more servers. Okay, you'll pay to the hosting provider for that amount of time. Difference is that like in things like Amazon with AWS, you can get spot pricing. So they've got spare capacity and you sort of bid for, I want some of that. The advantage with someone like in Google is that you can do it per minute. So I think Amazon is a compute hour and Google is, you spin them up, spin them down, you're only paying for when they're up. So we want to have that sort of capability to offer people as well so that where they want more grunt, they can get more grunt just for the amount of time that they want it. So those are the things that we're trying to do.
Sometimes when you get an algorithm from someone else, you realize that no matter how many nodes you can spin, it's still going to perform terribly, only because, like, for example, you can change the precision
So I'm lucky in terms of my chief data scientist is a very clever PhD doctorate, and so I basically, oh, you want to run this? I go, fine, Lewis. Yeah, here's a new algorithm. So he basically will bless. So that's why we need the source code. One, not that it doesn't do anything bad, but two, also is for Lewis to be able to have a look and say, okay, I understand what that algorithm's trying to do.
Just on that point, what are you using for Spark's resource management strategy? Is it Spark native or?
Spark native at the moment.
Okay, thank you very much.
All right.